Hello, this is Information Service Engineering, lecture number 6, putting it all together. This will be the third part of the knowledge mining and information extraction. So, here we will do a hands-on on data analysis example task. This is the continuation of the task we started in the previous part of the lecture, so you remember, back then we gathered all the data regarding the soccer players from Wikidata, and now we are going to really do the analysis together. So this is the data we have still. You have there the link if you want to go and investigate a bit and play with the data around. And this is just a screenshot of some of the analysis we can do with those data. But let's try to do this now together. So I'm going back here. Here we have again a collaborative notebook and we will do this analysis in Python. So the first step we do here, as always, is to do the necessary imports, to import the necessary packages of that it works for both Python 2 and 3, and that we have here some nice plots. And the next step is here, because we have to read from the Google spreadsheet, so I have to do that. And this step is to authenticate and give access to our account in the Google spreadsheet. So for you, probably the first time it will ask for some credentials. For me, it didn't ask because I did it already before. Just you copy paste it there and it's nothing more. Perfect. So now we are ready to start. We will start by loading our data, and we are going to load our data into this pandas comfortable data structure we have here in Python. It's a really cool thing. If you want to read more, there is a link here. You can go and read more about pandas. So what we do this import pandas, and we give a name to our data structure which we are going to call goals. And here, of course, we have to give the file path, the path to the file where we have our data. And as you notice here, it is split into 3 parts. The first part is about the Google Drive, then is the Google Sheet itself, the ID of the Google Sheet itself, and this is another ID which we give in case we have different tabs in this specific Google Sheet. And this is how we just import the data into the pandas structure. This line here is going to give me the top 10 lines or top 10 elements of this data structure pandas that we have, those that they were inserted first. So I execute it, and you will see here, of course, those top elements so that we can investigate if everything went well, if we imported correctly our data, and what type of data we have finally, because we didn't say. So what do we have? We have a column which is about the total number of goals, obviously per soccer player, a column about height, a column about the weight, a column about the birth year, a column about the position they play, and the birth date they have. So this is the type of data we store, and this is the data we are going to use to make our analysis. And let us start. So the first thing we do is we want to get some inside information or describe the data, and we do it in this way, goals.describe. And this is the information we get about the data, and actually it's the information we get about the numerical data we have, because you see here we have total goals, height, weight, and year. We don't have the position or the birth date, the complete birth date. And let's see what information we get for those. So here we have the count, how many instances we have with those attributes. Next we have the mean value of these attributes. We explained in the previous lecture what is the mean. Then we have the standard deviation here, the minimum value each of those columns or attributes get. What is the value in the 25%, what is the value in 50%, what is the value at 75%, something that we need for the box plots we are going to plot later, and then the maximum value. So let's see if we can already get some information from this basic analysis here. Something that we see here is that the standard deviation for the total goals is rather high in comparison to the other standard deviations here and to the mean value we have for the total goal. So that might already ring a bell. And if I combine this information, given that the minimum value that we get for total goals is 0, while the maximum is like almost 2000, well, this definitely tells us something. Let's check for more. Okay, so what we see here is that for the 75% of the data, the value is 42. For me, what we say here is that obviously the 75% of the data, they are there around value 42, but there are some few data where they have really large values. So apparently there are some very few people that they scored crazy amount of goals here. It might be true, it might be an error in the data. This is not our place here to judge. This is only what we notice from the data we have. And let us continue with the real analysis now, and let's start plotting some figures here. We will start plotting some histograms. So we have a histogram about height, total goals, weight, and year. Okay, what is the information we get from here? Okay, what we see here regarding height, that is a standard distribution, let's say, where the most of the people are having an average height and there are really few people having low and really high height. Similar is the case for the weight as well. Most of the people, they are there in the average and there are really few before and after. Regarding the total goals, what we can say is that most of the football or soccer players scored like a small amount of goals, small number of goals, and there are really few here in these cases where they scored lots of goals, which is something that we guessed before, a bit before from the data we had, so we see it here. And regarding the year of birth, what we see is that we have most of the players born here around 1980 to 1990 and to 2000, and then really few people from the 1900s. So that might mean that soccer was not popular back then, or simply we don't have this data in Wikidata, which might be actually the case. Okay, let's try now to plot some box plots, and we do it here. So we print the box plots about everything here. So we have the box plot about the total goals, a box plot about height, the weight, and the year of birth. So you see the difference for those box plots. That is because of the different range in the values they get. So in the year we have like something like 1990, while in the height we might have 1.8 or so. So let's try to plot these box plots independently, and we start with the total goals. So here we have the box plot about the total goals alone. And if you're wondering why all this empty space, that is because of probably the outliers we have, the values that they are really higher below, it's outside of the 75% of the data, and they are outliers. Okay, let's continue plotting a box plot about the height here, this is how it looks, as we expected. The mean is there around, the median is there around 180 centimeters. And then we continue to the weight, again, as it was expected, around 70 and 80, most of the people. And let's now try to plot a box plot about total goals by position, meaning the position that the football or soccer players have. So these box plots, they are going to look like this. This is ordered in, this is an alphabetic order, and here we have the different box plots regarding the total goals for the different position. So what we can already say is that forward is a position that probably they score lots of goals in comparison to goalkeeper, which sounds reasonable. And let us continue. So let's continue and plot some of the numbers regarding the position that the football or soccer players have. So most of the people, they have this position here, while then they come the defenders, then the forwards, and so on and so forth. And then in the end we have some playmaker. I don't know if that is a position. And if we continue, we can plot similar numbers regarding the birth year and the number of soccer players that they were born that year. So we see that most of the soccer players that exist now in Wikidata, they were born there around 1988, 89 until 1990 and 91. Let's say most of them, they were born those years. And then we have some few cases where they were born before or after. And let's here make another plot. Let's plot a scatter plot regarding the year of birth and the total goals. So here is the year of birth for the soccer players, and this is the total number of goals they scored. So, okay, we see here some normal expected things, that there are some soccer players, they scored a lot, some others, most of them, they scored fewer goals. But what we can say here is that, look, those people that they were born around 2000, they scored less goals, which makes sense because I suppose those people, they just started their career, while the people that they were born there in the end of 1980s, they already have their career, so obviously they have already scored much more goals than the younger ones. And let's continue, plot another scatter plot here, that we will have much more attributes, that's why it looks fancier here. So we have the year, so the height, the weight, the total goals, which is this, the bubbles that we have here in the scatter plot, and the year. And let's see if there is a correlation. So the correlation that we can see here is between the height and the weight of people, which might make sense. But let's try to print actually this correlation. So we see that we have weak correlations everywhere, apart from maybe this one, which is again a weak, although negative correlation with the year. We cannot really say how to explain it. But up to now we did all our analysis based on the numerical data we have. We didn't touch really much the position because this is not numerical data, so we couldn't do any statistics. If we want to do analysis based on the position, we can encode it into numerical values as well, and this is what I'm going to do here now. So I'm going to encode the position into numerical values, and here is, I just print a sample of the first 10 positions and I see here the values. But if we want to print all of them, so here are all the positions we have, and each one is assigned a value. So this is 0, goalkeeper is 0, forward is 1, defender is 2, and so on and so forth, so that we can make the analysis. Let's print again our data to see now how our data look like. And what we see here an extra column with the position number, not only the position itself, but the position number. You see goalkeeper 0, forward 1, so on and so forth. So let's try to do now some analysis using this position number as well, and plot a scatter plot here with the position number and the total goals. We have the total goals here and the position number, and we see that some positions, for example the 4 or 1, they scored much more goals than those positions here, 8, 9, 10, 11, and so on and so forth. So if we make here another scatter plot with more attributes, with height, weight, position number, and year, what we can say is probably that we see here mostly this blue-greenish color, so most of the goals were scored by those people apparently, and not by the other ones in the red colors. And again, if we want to check which is the position that has each ID number, we can do it in this way. So great. Going back to our slides, that was the analysis we made with the data we collected from Wikidata regarding soccer players. You have the code there and the data, you can play around with them. You can collect even more data if you want from Wikidata or another source and use all the methods provided, or even plot different things and do different analysis. Just play around. I find it very interesting. I hope you find it too. So In the next part, we are going to have the last part of knowledge mining and information extraction.